A native red seaweed used in stock feeds has shown great potential to reduce methane emissions from ruminant animals. The Cawthron Institute in Nelson has received funding to investigate the best ways of producing this seaweed in commercial quantities.
Starting globally first, algae are just hugely important as part of our ecosystem. They're responsible for maintaining atmospheric oxygen. If you think of seaweed and phytoplankton, they're essential for the existence of the planet and the continuation of a healthy planet. Coming close to home, algae are important for us in New Zealand because I think we're on the verge of establishing a new sector in aquaculture, an algae-based sector. I think you know that aquaculture is a primary sector that is growing very quickly versus other sectors, and seaweed aquaculture, microalgae aquaculture are kind of at the bottom of an S-curve. Great opportunities for the future for New Zealand in that space.
Asparagus is a very cool red algae that has quite interesting properties because it contains a chemical known as bromoform, and when you feed this to ruminants, it inhibits the production of methane, so it reduces significantly the release of methane to the atmosphere. So it's a seaweed that we would like to evaluate as a food additive to reduce emissions from cattle. We're looking at trying to grow Asparagus in a controlled way. So we are on top of the different life stages. So we can produce it when we want. So we can create seedlings. So we can, in the future, farm it on large scale. Also, the seaweed itself produces this bioactive component. So we need to understand when it does it and why. So we could tweak it and control it so we know we are continuously producing an algae with the right content of the compound. For us, one of the main questions is perhaps whether if we should try to grow it floating or if we should try to grow it attached to ropes or any other materials, and that would then dictate how you can grow this on large scale. Currently, we're looking at something that we like to refer to as pom-poms, where they form floating structures, small balls of mature algal tissue, and that's the stuff we're looking at now and trying to get it to reproduce. It lives in the coastal waters attached to rocks, but you can also find it in summer when it forms these floating ones. You can collect them off the beaches. So in here we got the pom-poms. These are the ones that were collected earlier from Whitebrook Cove on the North Island. So they come, as I tell you, as a little dirty ball. So we need to clean them up. And then we're going to try to make them reproduce. We're going to try to make more of these. Understand how to get them to transition from this stage to the gametophyte stage. It comes in straight from nature, so we have to clean it because it's a mess. It's a ball of yarn with bacteria. There's other algae, there are worms, and so we want to keep them clean. So that's actually one of the challenges, is to clean it, because it's not a piece of kelp. It's a ball of yarn, basically. So there are a few technological challenges, so we get a clean starting material.
When we got the samples, they looked like they were all just Asparagus, and then it's not till you get in.
At Cawthron, we probably have about at least 10 people working on seaweed or Asparagus. It's a one-year project, and we're about 4 months into it. It forms the basis for a larger project going for 5 years, also focusing on other seaweed and enabling technologies to grow seaweed in New Zealand on large scale.
It looks like it's pulling apart.
Yep. That's fine.
We're at the really, really early stages of this work. Part of the impetus for doing the work is that there's been these studies overseas which have shown that it reduces methane reduction in livestock, but one of the challenges with those studies is being able to get enough biomass for them to actually do their trials. And so what we'd like to be able to do is to help close the life cycle on this seaweed, help grow enough of it so that we can go on and really investigate whether it's something that is worth taking forward for the industry. We're in the process of getting the Algal Research Centre up and running, and we already have tanks where we're starting to try to grow this at a larger scale than just in the laboratory.
And with any luck, it'll grow like Billy-o, and each one will turn into a nice big fat compound that will be used.
If this research is successful, we'll need to be growing much, much more of it, and we'll either be looking to do that on land or on water and existing marine space that's used for farming.
About 50% of them go to the surface and 50% go to the bottom, so I'm not sure what that's about.
Asparagus work, the red seaweed, is exciting for us in a number of ways. I mean, it's great to see maybe one industry, aquaculture, or one sector of the primary sector being able to help another if we can. And also it's a great opportunity for our scientists who are primarily involved in aquaculture to be doing something active in climate change. So that's a real win-win for us. Our National Algae Research Centre, or ARC or NARC, that's a really exciting initiative that we have with the Provincial Growth Fund and MB to really crank up this idea of generating a new sector in aquaculture. So in that facility, we'll be doing prototyping of production systems for microalgae, the single-cell seaweeds, and macroalgae, the larger seaweeds, red, brown and green seaweeds, and working out how to grow them, because it's great having an application for a seaweed, but the trick is being able to bulk up and produce biomass. So we'll be working those out and how to optimize those processes in the Algae Research Centre, as well as with our partners and overseas collaborators and in the industry in New Zealand, the applications, whether it's cosmetic, pharma, nutraceutical or whatever.
Thanks, New Zealand On Air.